compound interest is the interest calculated not only the original amount of money, but also on the interest that has already been added. This means the money grows faster over time because interest earns interest. Compound interest is commonly used in savings accounts, investments, and loans. The longer time period and the higher the interest rate, the greater the total amount accumulated. In this chapter, we will learn how compound interest works and how to calculate it.
Now I will explain chapter 4, annuity. What is an annuity? Annuity is a series of equal payments that are made at equal time intervals. This means the amount of money is the same, the time between each payment is the same. Examples of annuity: shop rental payments, insurance policy payments, installment payments, and loan repayments. Term of an annuity. The term of an annuity is the total time taken from the beginning of the first payment until the end of the last payment. In simple words, it is the total duration of the payments. Payments interval. A payment interval is the time between each payment. For example, monthly, quarterly, and yearly. Now, I will explain the calculation for this question. On this slide, we can see the information written that K equals to 0.041, M equals to 4 because interest is compounded quarterly, T equals to 8 years, S equals to 180,547 ringgit and 26 cents. These are the values we will use in the equation. Next, we need to find the interest per period. The formula we use is I equals to K over M. So we need to substitute the given values. I equals to 0.041 over 4. Next, we need to find the number of compounding periods. The equation shown on this slide is N equals to M times T. So we need to substitute the values. N equals to 4 times 8. So the answer is 32. The formula on this slide is P equals to S, open bracket, 1 plus I, close bracket, to the power of negative N. So we need to substitute all values into the present value formula. The calculation is written that P equals to 180,547 ringgit and 26 cents, open bracket, 1 plus 0.041 over 4, close bracket, to the power of negative 32. After performing the calculation, the value of P is 130,276 ringgit and 90 cents. Explain the calculation for question B. Okay, on this slide, we can see the information written that S equals to 180,547 ringgit and 26 cents, P equals to 130,276 ringgit and 90 cents. These are the values we will use in the formula for total interest. The formula on this slide is I equals to S minus P. So we need to substitute the numbers we have. So I equals to 180,547 ringgit and 26 cents minus 130,276 ringgit and 90 cents. So the total interest Hakim earned is 50,270 ringgit and 36 cents.
To solve this, we use the compound interest formula, which is S equals to P times 1 plus I all to the power of N. Here, S is the future value, P is the principal, and I is the interest rate per compounding period, and N equals to M multiple with T, which represents the total number of compounding periods. And then we substitute the values into the formula, which is 250,000 equals to 130,276 ringgit and 90 cents multiplied by 1.0103 to the power of T. Next, we divide both sides of the equation. This gives us 1.9190. So now we have 1.0103 to the power of 4t equals 1.9190. To solve t, we take the logarithm of both sides. And then we get 4t times log of 1.0103 equals log of 1.9190. And then we isolate t by dividing, and finally we multiply by 1/4. After calculating, we find that t equals to 15.90x years, which is approximately 16 years. So it will take around 16 years for Mr. Hakim's savings to reach Rm 250,000 at the given rate. We begin with the compound interest formula. So S equals P times 1 plus K over 4 to the power of 4t. Since compounding is quarterly, so the M is equals to 4. And then we substitute the values into the formula. So 300,000 equals 130,276 ringgit and 90 cents multiplied by 1 plus k over 4 to the power of 20. 20 comes from 4 times 5 years. Next, we divide both sides. 300,000 divided by 130,276.90 gives us 2.3028. So now we have 1 plus k over 4 raised to the power of 20 equals to 2.3028. To solve for k, we take the 20th root. 1 plus k over 4 equals the 20th root for 2.3028, which gives us approximately 1.0426. And then we isolate k. K over 4 equals 1.0426 minus 1, and then that gives us 0.0426. Finally, we multiply by 4 to get k, the nominal annual interest rate. K equals 0.0426 times 4, which gives us 0.1704 or 17.04% nominal annual interest. To find the quarterly periodic rate, we simply divide by 4 again. 0.1704 divided by 4 gives 0.0426 or 4.26% per quarter.
For the equation, we need to find the emergency value. To know the answer, we must calculate by using feature annuity formula, which is H equal R equal periodic payment, and the total is 500. Bracket 1 plus I bracket power n minus 1 over I. First, we must calculate periodic interest rate. 0.04 need to divide by 4 to get 0.01. Then we need to time multiply frequency, which is 5 times 4 to get term of the loan is 20. After this, insert all the information into the formula and we can get 11,009.50. And then after we solve half of the mini, we should divide 2 so that we can get R new, which is Rn 5,504.57. Lastly, we should use formula S equal P new bracket 1 plus I bracket power n, because we need to find amount at the end of 2 years in ABC bank account. First, we must calculate number of interest period, which is frequency multiply time, and we can get 24. And interest rate is 0.06, and we should use formula I equal K over M. After this, insert all the information into the formula and we can get 6,204.73.
For the question B1, finding the number of monthly payment Rabiatul needs to borrow 18,000 ringgit, which is the cost of the machine 100,000 ringgit minus the trade-in value 20,000 ringgit. Since she repays the loan through his monthly installment, we use the annuity formula A equal R bracket 1 minus bracket 1 plus I bracket minus M over I bracket substitute A equal 18,000 ringgit, R equal 1779.56 ringgit, and I 0.12 over 12 equal 1.01. Solve for nursing logarithms and obtain and 16. Therefore, she must take 16 monthly payment. Question 2. Amount to pay if she missed her 6th payment. The amount due on the 7th payment includes the normal installment plus the accumulated value of the missed payment. We use the future value of an annuity as equal of bracket 1 plus I minus H minus 1 over I bracket with R 11779.56 ringgit. I equal 0.01 and n equal 7. The amount become Rm 12836.92. Last question. Final statement after 14 payment. Rabiatul wants to settle the loan after paying 14 installment. Since the total required payment were 16, the remaining number is 20. We calculate the present value of the remaining installment. A equal R bracket 1 minus bracket 1 plus I bracket minus n over I bracket. Using R equal 11779.56 ringgit, I equal 0.01 and n equal 20. The final statement amount is Rm 32113.14.